Hello students, welcome to EPG Pathshala. Today we shall be talking about the applications of remote sensing and GIS in disaster management. So to begin with this module, we shall first study what are the types of disaster, how does a hazard become a disaster, and we will also study the risk associated with a disaster, that how any risk is a product of the hazard and the vulnerability that is associated with it. So, after studying the types of disaster, we will come to disaster management cycle that primarily includes the 4 phases of disaster management. The first one is mitigation, the second one is emergency response or preparedness, the third one is response, and the fourth one is recovery. So, the entire process of disaster management cycle can basically be divided into 3 phases. The one that occurs before a disaster, which we call as pre-disaster phase, and it basically includes the mitigation and preparedness activities. The second one is during the occurrence of a disaster, that basically includes the emergency response mechanisms, and the last one is post disaster, that occurs after the occurrence of a disaster, and it mainly includes the relief and rehabilitation measures. So, after that we shall also be studying how remote sensing and GIS, that is the geographical information system, that is helpful in managing these disasters both before and after the occurrence, including during the occurrence of a disaster. So, let us begin with the module now. So, as you all know, for mankind disasters are unavoidable in nature, that means it cannot be avoided. The only thing is that the risk associated with it can be minimized, and they have been recurrent events despite having various problems ever since time immortal. So, the disasters, they cause threat to human settlement, economic assets, and are supposed to have high risk proportions in areas of dense population. It is for this reason that most of the world's nastiest disasters, they tend to occur between the Tropic of Cancer and the Tropic of Capricorn. In 2015, Asia Pacific belt remained as the world's most disaster prone region. Around 160 disasters out of the world's 344 recorded ones were reported in this region, which account for 47% of the total disasters. The population that is affected by such calamities, it was about 59.3 millions, with a total of more than 16,046 deaths in the region. South Asia, it went through the highest percentage of fatalities with a total of 14,647 deaths. So, this is about 64% of the total 52 disasters that took place in the year 2015, out of which the maximum deaths, that means around 8,790, were reported from Nepal earthquake tragedy. Further, the total economic loss in Asia and the Pacific was more than 45.1 billion US dollars in the year 2015. This does not include more of the indirect losses that also happened. So, about 90 storms were recorded worldwide that took place in 2015, out of which half of these storms, they occurred in Asia Pacific region, affecting 9 million inhabitants with a loss of US dollar 11.8 billions. 2/5 of all disasters was related to floods, responsible for about 37% damage to human lives and 25% economic loss. So, if we look at the Indian scenario, the Indian subcontinent is susceptible to various natural disasters such as drought, cyclones, tsunamis, floods, earthquake, forest fire, landslides and avalanches. Further, out of the 35 total states and union territories in the country, 25 are prone to disasters. So, in the country on an average about 50 million people are affected by disaster every year. Also, $1 million of loss of property occurs. So, coming to what is a disaster is a sudden accident or a natural calamity that leads to serious damage to property or the lives of living beings. According to World Health Organization, a disaster can be defined as any occurrence that causes damage, ecological disruption, loss of human life, deterioration of health and health services on a scale, deterioration of health and health related services on a large scale that is sufficient to warrant an extraordinary response from outside that affected the community or area. Further, a disaster is a major adverse event or disruption that occurs over a relatively shorter time, resulting from natural or human induced activities that causes heavy damage to human life, material, environment or economy, thus making it difficult to combat such losses. During such calamity, developing countries go through higher costs compared to the developed ones, that implying more than 95% of all deaths caused by calamities in developing countries, and losses due to natural events are 20 times greater in developing countries than in developed countries. Coming to the types of disasters, basically there are two types of disasters. One is natural, which is caused by natural forces and is beyond human control, and the second one is man-made disaster, which generally owes its origin to anthropogenic causes. So, coming to the first one, that is the natural disaster. It is a type of disaster that happens due to natural process or phenomena causing damage to lives, health, property, environment and economy of the region. This type of disaster includes earthquakes, volcanoes, landslides, floods, storms, hurricanes and tornadoes, tsunami and cyclones, thus killing people on large scale and cause billions of dollars damage to property and the environment every year worldwide. Today, however, due to population explosion and urbanization, there is a sharp increase in severity of damage due to these frequent disasters. There are some disasters that happen without any warning, such as earthquakes and tornadoes, causing much more damage unexpectedly to infrastructure and other productive capacity. Storms like hurricanes and typhoons are considered as one of the most seriously damaging natural calamities because of their size and magnitude. Further, disasters like floods and cyclones also cause damage to a larger extent to both infrastructure and agriculture. Now, coming to the second category, that is the man-made disasters. They are the end results of human error or technological hazards. For example, fires, stampedes, industrial accidents, oil spills, transport accidents, war and nuclear explosions or radiations are some of the examples of man-made disasters. Like natural disasters, these events also cause serious damage to human life, property and economy of the state. Disasters have been categorized into different subgroups depending on their origin. The 5 major subgroups are given below. The first one is water and climate related disasters. This includes cyclones, tornadoes, hurricanes, heat wave and cold wave, avalanches, floods, droughts, hailstorm, sea erosion, thunder, cloudburst and lightning. The second category is of geologically related disasters. This includes landslides, mud flows, dam failures, dam bursts, mine fires and earthquakes. The third subgroup is of chemical, industrial and nuclear related disasters, which mainly accounts for the industries pertaining to chemicals and nuclear related disasters. The fourth one is accident related disasters, which includes oil spill, building collapse, bomb blasts, festival related disasters, electrical disasters, and fire, forest fire, urban fire and transport related accidents. The last subgroup is of biologically related disasters, which includes pest attacks, biological disasters and epidemics. That also includes cattle epidemics and food poisoning. So, let us see some of these natural and man-made disasters in a bit of detail. The first one is tropical cyclones. Tropical cyclones, which we generally call as cyclones, is the term that is used globally to cover tropical weather systems in which winds equal or exceed the gale force, that is a minimum of 34 knots or 62 kilometers per hour. Further, these are intense low pressure areas of the earth atmosphere coupled system and are extreme weather events of the tropics. Although the North Indian Ocean Basin, which we also call as NIO Basin, including the Indian coast, it generates only about 7% of the world's cyclones. However, their impact is comparatively high and devastating, especially when they strike the coasts bordering the North Bay of Bengal. The frequency of these cyclones is bimodal, which is specific to this region, which implies cyclones occur in the months of May, June and October, November, with their primary peak in November and secondary peak in May. As per broad scale assessment of the population at risk, nearly one-third of India's population is vulnerable to cyclone related hazards. Climate change, with the resultant sea level rise and expected increase in severity of cyclones, can significantly increase the vulnerability of the coastal population. Further, there are 13 coastal states and union territories in the country, encompassing 84 coastal districts which are affected by tropical cyclones. 4 states, Tamil Nadu, Andhra Pradesh, Odisha and West Bengal, and 1 union territory, that is Puducherry on the east coast, and 1 state, Gujarat, on the west coast, are highly vulnerable to cyclone disasters. The next one is storm surge. It is a coastal phenomena and is the inherent destructive aspect of cyclones the world over. Storm surge is an abnormal rise of water generated by a storm over and above the predicted astronomical tides. Further, a storm surge should not be confused with a storm tide. The rise in water level can cause extreme flooding in coastal areas, particularly when storm surge coincides with normal high tide, resulting in storm tides reaching up to 6 meters or more in some cases. The degree of destructive potential depends on the storm surge amplitude that is associated with the cyclone. Most casualties during tropical cyclones occur as the result of storm surges. Now coming to the next natural disaster, that is a flood. On an average, floods affect about 7.5 million hectares of area per year. According to the National Commission on Floods, the area susceptible to floods was estimated in 1980s to be around 40 million hectares, and further it is possible to provide reasonable degree of protection to nearly 80%, that means 32 million hectares of land. Riverine flooding is perhaps the most critical climate related hazard in India. The flood control is a key element of national policies for water resource management as well. The occurrence of floods and drought is closely linked to the summer monsoon activity. The floods, they occur in almost all river basins of the country. Heavy rainfall, inadequate capacity of rivers to carry the high flood discharge, inadequate drainage to carry away the rainwater quickly to streams or rivers are the main causes of floods. Ice dams or landslides that block the streams besides cyclones also cause the floods. Out of 40 million hectare of the flood prone area in the country, on an average the floods affect an area of around 7.5 million hectares per year. Floods in the Indo-Gangetic Brahmaputra plains are an annual feature. On an average, a few hundred lives are lost, millions of people are rendered homeless, lakhs of hectares of crops are damaged, and thousands of animals are affected during a flood. The National Flood Control Program was launched in 1954. Since then, a sizable progress has been made in the flood protection measures, which includes both structural as well as the non-structural measures. After the floods, urban floods is a separate category of floods that has been gaining greater attention in the recent years due to the rising urban areas or urban sprawl in the country. The problem of urban flooding is a result of both natural factors and land use changes brought about by urban development. Urban flooding is caused by the combination of meteorological, hydrological and human factors. Urban flooding is significantly different from rural flooding as urbanization leads to developed catchments which increases the flood peaks from 1.8 to 8 times and the flood volumes by up to 6 times. Consequently, flooding occurs very quickly due to faster flow times, sometimes in a matter of minutes. The challenges of urban floods disaster management tend to be considerably different from that of flooding in other areas. In 2010, the National Disaster Management Authority published a separate guidelines for urban floods disaster management. Problems that are associated with the urban floods, they range from relatively localized incidents to major incidents resulting in inundation of some or large parts of urban areas for several hours to many days. The impact can vary from being limited to widespread. It may result in temporary relocation of people, dispersal of animals, damage to civic amenities, deterioration of water quality and risk of epidemics. Another natural disaster is earthquake, and if we look at Indian territory, nearly 59% of its area is vulnerable to earthquakes. The last three major earthquakes shook Gujarat in January 2001, Jammu and Kashmir in October 2005 and Sikkim in 2011. Many smaller earthquakes have been occurring in various parts of India. The seven states in northeast, that is Assam, Arunachal, Nagaland, Manipur, Mizoram, Tripura and Meghalaya, the Andaman and Nicobar Islands, the parts of three states in the north or northwest, that is Jammu and Kashmir, Uttarakhand, Bihar and Gujarat are in seismic zone of 5. The widespread human and material losses, collapse of infrastructure and services may be the major consequences of earthquake. Hundreds of thousands may be displaced, often in remote mountainous areas in the north and northeast. Although we have discussed tropical cyclones earlier, let's have a look at tsunami. It's a Japanese term for harbor wave, also known as seismic sea wave, and it's a series of very large waves with extremely long wavelength, maybe 100 kilometers or more. It is usually generated by sudden displacements in the seafloor caused by earthquake, landslides or volcanic activity. Most tsunamis usually occur near geological plate boundaries or fault lines where geological plates collide. When the seafloor abruptly deforms, the sudden vertical displacement over large areas disturb the ocean surface, displace water and generate tsunami waves. The waves could travel away from the triggering source with speeds exceeding 800 km per hour over very long distances. They could be extremely dangerous and damaging when they reach the coast, because when the tsunami enters shallow water in coastal areas, the wave velocity will decrease, accompanied by increase in wave height. In shallow waters, a large tsunami crest height may rise rapidly by several meters, even in excess of 30 meters, causing enormous destruction in a very short time. Another disaster which commonly occurs in the hilly terrains is landslides. So, in India, it generally occurs in the hilly regions of the Himalayas, the northeast India, the Nilgiris, the eastern Ghats and the western Ghats. It is estimated that 30% of the world's landslides occur in Himalayan ranges, since they are young mountains which are continuously rising. Landslides are also common in western Ghats. In the Nilgiris, in 1978 alone, unprecedented rains in the region triggered about 100 landslides, which cause severe damage to communication lines, tea gardens, and other cultivated crops. Scientific observations in North Sikkim and Garhwal regions of Himalayas clearly reveal that there is an average of 2 landslides per square kilometer. The mean rate of land loss is to the tune of 120 meters per kilometer per year, and annual soil loss is about 2500 tons per square kilometer. Landslides have been a major and widely spread natural disaster that often affects life and property, leading to major concern. Another category is snow avalanches, which are blocks of snow or ice descending from the mountain tops at a river. The next disaster is snow avalanches, which are blocks of snow or ice descending from the mountain tops at a very high speed like a flowing river. They are extremely damaging and cause huge loss to life and property. In Himalayas, avalanches are common in Dras, Pir Panjal, Lahaul Spiti and Badrinath areas. As per the Snow and Avalanches Study Establishment of the Defence Research and Development Organization, that is DRDO, on an average around 30 people are killed every year due to landslides in various zones of the Himalayan range. Besides death of people, avalanches also damage the roads, properties and settlements falling in its way. Traffic blockage, structural damage of roads and retaining wall damages occur most frequently due to avalanches. Snow avalanches occur in several stretches of the Himalayan range, with the following areas being more vulnerable. The first one is Western Himalayas, that includes the snowy regions of Jammu and Kashmir, Himachal Pradesh and Uttarakhand, especially the Tehri Garhwal and Chamoli districts. The next is Jammu and Kashmir region, which includes the higher reaches of Kashmir and Gurez valleys, Kargil and Ladakh, besides some of the major roads. The last one in this is Himachal Pradesh, which includes Chamba, Kulu, Spiti and Kinnaur. Coming to the next disaster, which is a drought. As we look at the standard definition of drought, there is no globally adopted operational definition for this disaster. The Global Assessment Report 2015 notes that agricultural drought is probably the most socially constructed of all the disaster risks and warns that due to global climate change, its frequency is expected to be very high. To determine the beginning of drought, operational definitions specify the degrees of departure from the long term. That means usually at least 30 years, average of the precipitation or some other climatic variables. Drought affects vast areas of the country transcending the state boundaries. A third of the country is drought prone. Drought is a phenomena that is widely considered as a creeping disaster whose onset, end and severity are difficult to determine. Unlike the suddenly occurring disasters, a drought may develop very slowly over several months, affecting very large geographical area without causing little or no structural damage. The impacts they depend on natural conditions, socio-economic situations and the kind of land and water resources as well as the land use patterns in the affected region. Mostly, the occurrence of droughts is a result of natural climate variability in all the drought prone regions and it usually exhibits a certain pattern of occurrence. While droughts are quite frequent in arid and semi-arid areas, it can occur even in humid regions blessed with abundant rainfall but with a lower frequency. The capacity to cope with a drought depends largely on the technical, institutional, political and social mechanisms to manage the water resources anticipating the severity of the drought. Effective mitigation measures must prevent a drought turning into a famine due to water and food shortages. Droughts result from long period of dry weather and insufficient precipitation, which causes acute dry conditions. The National Commission on Agriculture in India defines the three types of droughts: meteorological drought, agricultural drought and hydrological drought. The meteorological drought is defined as a situation when there is a significant decrease from normal precipitation over an area. That means it's more than 10%. The agricultural drought signifies the situation when soil moisture and rainfall are inadequate to support healthy crop growth. The third one is hydrological drought, that results from prolonged meteorological drought manifested in depletion of surface and subsurface water resources, which could occur even when the rainfall is normal if there has been a substantial reduction in surface water holding capacity. So, in the absence of an unambiguous criteria, the NDMA guidelines on management of drought notes that there is a need to develop a multi-criteria index to classify droughts based on several factors such as meteorological, that includes rainfall and temperature, soil conditions, that includes depth, type, available water content, etc. The surface water use, that is the proportion of irrigated area, surface water supplies, etc. The groundwater availability and utilization. The crops such as changes in cropping pattern, land use, crop conditions, anomalies in crop condition, etc. The last one is socio-economic conditions, which includes proportion of weaker sections, poverty, the size class of farm holdings, and so on. While drought proofing measures can significantly improve the coping capacity and dampen the impact of drought, if drought conditions worsen, many agencies of the state and center will have to work in coordination to prevent actual rural distress. Since the progression of droughts is slow, agencies can respond by closely monitoring the situation using various technical capabilities available. The next is cold wave and frost, which is a seasonal and localized hazard that occurs in parts of the country experiencing severe winter. So, the prolonged frost conditions and cold wave can damage certain frost sensitive plants, causing the crops loss. The susceptibility to frost varies widely across crops. The extent of damage caused by cold wave depends on temperature, length of exposure, humidity levels, and the speed at which freezing temperature is reached. It is difficult to predict a definite temperature level up to which the crops can tolerate cold wave or a frost because many other factors also affect it. It can cause death and injury to human beings, livestock, and wildlife. Further, if a cold wave is accompanied by heavy and persistent snow, the grazing animals may be unable to get the requisite food. They may die of hypothermia from prolonged exposure or out of starvation. Now coming to the man-induced disasters, the first one is oil spill. It can occur during oil transportation or storage, spillage in water, ice, or on land. It can be highly dangerous since wind, waves, and currents can scatter a large oil spill over a wide area within a few hours in the open sea. Once an oil is spilled, it quickly spreads to form a thin layer on the water surface known as an oil slick. As time passes, the oil slick becomes thinner, forming a layer which is known as a sheen that gives us a rainbow-like appearance. So, is there any law that covers an oil spill disaster in India? If you observe closely, in India there is no law covering oil spill as such and its consequential environmental damage. These incidents are not covered as an oil spill but as an accidental discharge as defined in the Environmental Protection Act of 1986. Usually, FIRs are filed under EPA and according to IPC sections relating rash navigation and endangering the life of others. But India has the National Oil Spill Disaster Contingency Plan of 1996, which we call as NOSDCP, to handle such situations. The document was issued by the Ministry of Defence in 1996 and was last updated in March 2006. The other one is chemical or industrial disaster, and as you all know, with rising economic development and industrialization, there is a boom of the small, medium and large scale industries across the countries. However, there is a relatively higher presence of these industries along the west coast, largely due to the proximity to raw materials and ports. Due to the regional concentration of chemical companies in certain pockets, the chemical hazard has increased many folds. The growth of these industries has led to an increase in the risk of occurrence of incidents associated with hazardous chemicals, which we call as HAZChem. These events occur due to mishaps or failures in the industry and affect the industrial functions, property and productivity. While the common causes for these accidents are deficiency in safety management systems or human errors, the natural calamities or sabotage may also trigger such accidents. They are significant in having a long-term impact on the community and environment, leading to injuries, pain, suffering, loss of lives, damage to property and environment. Hence, a robust plan and mitigation measures are needed to be adapted to overcome this hazard. The next important category is of nuclear and radiological emergency. A nuclear disaster is caused due to an extraordinary release of radioactive material or radiation either in the operation of nuclear reactors or other nuclear events like explosion of a radiological dispersal device or improvised nuclear device or the explosion of a nuclear weapon. A nuclear or a radiological emergency is an incident resulting in or having a potential to result in exposure to and or contamination of the workers or the public in excess of the respective permissible limits. These emergencies are classified into 5 broad groups. The first one is an accident taking place in any nuclear facility of the nuclear fuel cycle, including the nuclear reactor, or in a facility using radioactive sources leading to large scale release of radioactivity in the environment. A criticality accident in a nuclear fuel cycle facility where an uncontrolled nuclear chain reaction takes place, inadvertently leading to bursts of neutrons and gamma radiation, as that happened in Japan. The third one is an accident during the transportation of radioactive material. The next is the malevolent use of RDD or IND by terrorists, while the last one is a large-scale nuclear disaster resulting from a nuclear weapon attack which would lead to mass casualties and destruction of large area and properties. Unlike nuclear emergency, the impact of a nuclear disaster is beyond the coping capability of local authorities and calls for handling at the national level. So, a nuclear emergency refers to an emergency situation in which there is or is presumed to be a hazard due to the release of energy along with radiation from a nuclear chain reaction or from the decay of the products of a chain reaction. This covers accidents in nuclear reactors, criticality situations in fuel cycle facilities, nuclear explosions and so on. All other emergency situations which have the potential hazard of radiation exposure due to decay of radioisotopes are classified as radiological emergencies. Examples include accidents that took place in Brazil, San Salvador, Istanbul in Turkey, Panama, etc. The overall objective is to prevent NRE. Further, there is also a need to adequately prepare for such emergencies that must be managed through a well planned and established mechanism. It includes both structural and non-structural mechanisms in a manner that will minimize the risk to health, life and the environment. So, the 8 nuclear or radiological emergency scenarios envisaged in the disaster planning are listed here, such as accidents in the nuclear power plants, criticality accidents, accidents during transportation of radioactive material, at facilities using radioactive sources, the disintegration of satellites during re-entry, the nuclear or radiological terrorism and sabotage at nuclear facilities, the state-sponsored nuclear terrorism, and the explosion of nuclear weapons. The next in this category is fires, which can start due to human activities or from natural causes. So, it can be residential and non-residential structural fire that is usually caused by human activities. Most industrial and chemical fires are also triggered by human activities. The risk varies with geographical location such as hilly areas, coastal or desert areas, and with different types of residential buildings, maybe medium, low rise or high rise, industrial, commercial area, or a combination of these. The NDMA guidelines on fire services notes that the Standing Fire and Advisory Council has stressed that there is an urgent need to strengthen the fire and emergency services and overcome major shortcomings in the response and its capabilities. So, if we look at the applications of geospatial technology in disaster management, first we have to look at the definition of disaster management. It is the organization and management of resources and responsibilities while dealing with emergency situations within all humanitarian aspects during different stages, for example, preparedness, response and recovery, in order to reduce the impact and damage caused during disasters. So, in this process, the objectives of the concerned experts are to monitor the condition, simulate the disaster occurrence to have better models for prediction, propose suitable contingency plans, and finally prepare spatial database. So, the management of disasters can be done using remote sensing as well as GIS. A large amount of multitemporal spatial data is required for the management of natural disasters, and these techniques can be used effectively for the assessment of disaster severity and the subsequent impact of destruction. Besides remote sensing, the use of GIS has become equally important for cartography, that is map making and enumeration tasks. In any disaster management, the satellite data can be used during various phases such as preparedness, prevention, relief and reconstruction, and also for monitoring and warning tasks. Integrated with global positioning system, the GIS in disaster relief stage is very useful in search and rescue operations in the areas that are devastated by calamity. And in preventive phase, the GIS can be used to manage large amount of data needed for the assessment of vulnerability of the hazard. It can also be used for better planning, emergency operations, designing evacuation means during preparedness stage, and for the incorporation of satellite data with other significant ancillary data in proper design of a warning system. It can also be used in search and rescue operations during relief stage. The GIS can be used to organize the information related to damage due to disasters for census report and rehabilitation measures. The UN General Assembly resolution declared the period of 1990 to 2000 as the International Decade for Natural Disaster Reduction. In response to this, the Government of India has undertaken several initiatives, shifting the focus from post-disaster approach to the pre-disaster preparedness, including preparation of Vulnerability Atlas of India to minimize the loss to life and property as a result of these disasters. Besides, the Disaster Management Act 2005 lays down the institutional and coordination mechanism at national, state and district level. So, while managing these, if we look at the disasters planning at various stages and the levels, the High Power Committee on Disaster Management in its report of 2001 categorized disaster situations into three levels, L1, L2 and L3. The period of normalcy, that is L0, should be utilized for disaster risk reduction. However, the categorization of the disaster situations into these levels from 0 to 3 does not find any mention in the Disaster Management Act of 2005. It also does not have any provision for notifying any disaster as a national calamity or a national disaster. So, the L1 level of disaster can be managed with the capabilities and resources at the district level. The level L2 signifies the disaster situations that require assistance and active mobilization of resources at the state level and deployment of state level agencies for disaster management. The level 3 is corresponding to a nearly catastrophic situation or a very large scale disaster that overwhelms the state and district authorities. Further, the Building Material and Technology Promotion Council (BMTPC) has come out with Vulnerability Atlas of India as a tool for formulating proactive policies, strategies and programs to face the threat caused due to natural hazards. The Annexure 2 of this atlas has the hazard vulnerability maps of India for earthquake, floods and winds and cyclones. So, let us have a quick example of how these disasters can be managed using this geospatial technology. The first one being the earthquakes. To provide rapid and reliable assessment report of the destruction that is caused by earthquakes, the analysis of remote sensing images, in particular the high resolution aerial imagery, has been a very effective technology. Further, the techniques like photogrammetry and GIS are considered helpful in exploring the earthquakes and other associated phenomena. The methods like terrestrial photogrammetry was first time used to document and report the earthquake damages caused in Italy. So, currently there are several efforts to use remote sensing, photogrammetry and other information sciences and systems in the areas that are damaged by earthquakes. Some of them are associated with long term and short term prediction, and some are linked with recording and assessment of the damage that has been caused. The maps that are related to epicenter of the earthquake are used to generate seismic hazard maps. The seismic zoning happens to be a basic informative tool in the code for designing resistant structures that are related to earthquakes. So, this figure, it describes the seismic zones of India based on the risk associated with it. Besides the data that is associated with earthquake, the structural design, the geological factors, the data pertaining to soil are very useful for the preparation of building codes which aid in designing earthquake resistant structures. So, as mentioned earlier also, BMTPC, Ministry of Housing and Urban Poverty Alleviation, they collaborate with the national and international agencies for vulnerability analysis and mitigation practices. So, coming to the management of landslides, the use of satellite data, aerial photography and remote sensing techniques help in the data collection during the disaster. The computerized techniques and other systems would help in storage, retrieval and analysis of the data. In the preventive phase of disaster, the satellite images can be used for landslide inventory and the mapping of factors related to occurrence such as presence of faults, the lithology, the geomorphological setting, the slope, the land use and vegetation. Also, the satellites with a better spatial resolution and stereo capability are very helpful in recording and documentation of the past landslides. It is expected that in future very high resolution images such as Iconos would be useful for landslide inventory. For the classification of lithology, land use and vegetation, multispectral images are significantly important. Also, for geomorphological mapping or terrain classification, stereo spot images have been widely used. They can also be used to prepare digital elevation models. The techniques like GPS, photogrammetry and radar interferometry have been essential during preparedness stage. This figure describes the landslide zonation map of India that represents the varying degrees of predictable slope stability for determining landslides. This zonation map has an inbuilt factor of forecasting and consists of maps showing various degrees of slope stability, and therefore these maps are probabilistic in nature. It has the ability to aid in some of the following individual factor maps based on methodology and input data. For example, the landslide location, the slope steepness, the land use land cover, the geology, the density of drainage as well as the rainfall. If we look at the management of floods, many factors play a role in the occurrence of flooding. For example, the intensity and duration of rainfall, the snowmelt, the deforestation, changing land use practices, sedimentation in riverbeds, and natural or man-made obstructions. So, the figure represents the flood hazard zonation map of India, and it takes into account certain considerations such as the depth of flood water, the rate of rise and decline of water, the duration of rainfall, the flow velocity and the frequency of occurrence of floods. During the stages of preparedness and response, the Earth observation satellites are widely used. These satellites provide data for mapping geomorphological elements, historical events and sequential inundation phases, including the depth, duration and direction of current events during the prevention stage. The monitoring is carried out using satellite images from global scale to storm scale. In most of the disaster management phases, the satellite data has been effectively and operationally used for flood management. It is frequently used in the storm scale to monitor the movement, intensity and precipitation spread to determine how much, when and where the heavy precipitation is going to shift during the next maybe 3 hours. So, this is also called as nowcasting through hydrodynamic models. The synthetic aperture radar has been regularly observing the Earth's surface, and it can monitor even in bad weather conditions or thick cloud cover. The mapping of floods can also be done using NOAA AV HRR in near real time. Besides, from GOES and POES satellites, the multi-channel and multi-sensor data are used for meteorological evaluation, interpretation, validation and assimilation into numerical prediction models to assess hydrogeological risk. Also, for flood forecasting and subsequent warning, the quantitative precipitation estimates and forecast use satellite data as an informative source. Besides, for the mapping of flood inundated areas also, the synthetic aperture radar, the RadarSat and others have been used very effectively even in bad weather conditions. In India, since 1993, ERS SAR has been used effectively for flood monitoring since 1998. The GIS technique can contribute in generation of topographic information using digital elevation model that can be obtained from Indian remote sensing satellites, spot, aerial photography, geodetic surveys or the LIDAR or SAR images. So, dear students, at the end of this module, I hope you all are well versed with the various types of disaster, the concept of disaster, how it is related to the vulnerability that can be physical or social or economic or environmental. Besides studying the various types of disasters, we have also classified the disasters into natural and the man-made disasters. We have had an overview of a few of these natural and the man-made disasters. What are the guidelines present in India and the guidelines that have been given by the National Disaster Management Authority that is located at New Delhi. Also, we have studied the application of remote sensing, GIS and GPS that together constitute a geospatial technology for the monitoring and the effective management of these disasters. I hope you all have benefited from this module. Thank you.